Hello, everybody, and welcome to today's webinar presentation, Why You Should Not Be Using an RDBS for Time-Stamped Data, brought to you by InfluxData. I'd like to introduce you to our presenters. Our first presenter is Anais Dotis-Georgiou. Anais is a developer advocate for InfluxData with a passion for making data beautiful with the use of data analytics, AI, and machine learning. She takes the data she collects, does a mix of research, exploration, and engineering to translate the data into something of function, value, and beauty. Our next presenter is Katy Farmer. Katy lives in Oakland, California with her husband and 2 dogs. She loves to experiment with code, break stuff, and try to fix it. She learned to code at Turing School of Software and Design in Denver, Colorado, and it gave her the perfect chance to break stuff before she knew how to fix it.
Well, we already talked about who we are. Anais and I are both developer advocates at InfluxData. And if you're not familiar with that, that's okay. Our job is basically to be a technical representative of the community. Our products are used by developers, which means that traditional marketing sometimes has gaps in it. There's a language in tech that can be hard for people outside of the bubble to understand, and our job is to bridge the gap. So we're here today to teach you a little bit about time series, why a time series platform is important if you're dealing with specific kinds of data, and to answer any questions you have. So Anais, why don't you sort of take it away?
All right, sounds good. So just to begin, what is time series data? It's just a series of points in ordered time. And the characteristics include really high volume data that is or contains a timestamp. And it's more valuable than as a data set than a single point, because when you're taking or looking at time series data, you're usually looking at huge quantities of time series data.
Absolutely. So if you think about weather data, I think this is the perfect example because it's something everyone can understand. I live in the Bay Area in California, so it's important to know what temperature it is when I'm on my way to work. It's a very different temperature at my house than it is at my office. So if I look it up and I see that it's 62 degrees, that's valuable to me. But if I don't know what time it was 62 degrees, then that has almost no value to me. This is an example of the timestamp specifically adding value to the data. So not only that, but we can use it to learn. So I can tell you what temperature I think it's going to be tomorrow if I have enough data from, say, the past year, the past 5 years. The more data we have, the bigger our data set is, the more we can learn from it.
Another really common example of time series data is just stock price, where obviously being able to collect this data in huge volumes is very valuable. So a lot of times, if you're in the financial industry, you're going to be wanting to collect price data at the nanosecond precision. So this is one example why you will need a time series database, is because you need a database that's going to be able to support data at such high precisions. And before we go into Influx and why it's specifically made to handle this type of volume, I just wanted to talk about a couple of the attributes of time series data, and that includes trend and seasonality. So in this graph here, in these series of graphs, the first graph at the top is just our observed data, and we can see that it sort of increases with time, and that increase is referred to as the trend. And so whenever time series data has a trend, we refer to that data, that time series data, as being non-stationary. There's other examples of data that don't have a trend. Maybe, for example, page views might not have a trend if your customer base is remaining constant and your clients are remaining constant. Then maybe you would just see seasonality, but you wouldn't have a trend. And so the second or last attribute of time series data that I want to talk about is just the seasonal component. And that's just where you have cyclical or seasonal patterns in your data. And so you can remove the trend from your observed data and more easily discover or uncover the seasonality. And the residual is just merely the difference between the seasonal value and the trend.
So Anais, I have a question about that. If we're talking about data with a trend, so let's say that I'm like gathering data from my like personal website, which obviously has millions of viewers, and I'm keeping track of like every time someone gets like a 404, and that like continues to increase because there's something wrong with my like server, my hosting service. Would that be considered like a trending pattern?
Yeah, in that case, if you start to see any increase in any of your metrics, then you should see a trend. And then, for example, you might want to set some sort of alerting or threshold limit around a trend so that you know that you need to go investigate what's causing those errors.
Nice, cool, thanks. So we do want to talk about a couple things that are not time series data, because we live in a very like data fueled industry. So in this graphic, you can see the two axes are my mood and cake. Now, these are related, and this is just true for me as a person. My mood is affected by cake. But what we're looking at here is what we consider traditional relational data. Cake and my mood have a relationship, but time is not part of that relationship. Maybe my mood goes up or down. As you can see, there are some different behaviors in this, but it's pretty hard to make predictions about the trend of this data because it's not really well defined. So let's look at what this data set would look like if it was time series data. In this case, what we're looking at is on one axis, the time, and on the other, cake consumption events. So in other words, when I eat cake, what time is it? And you can start to see clusters here, right? So you might begin to ask, like, what is Katy doing between 10 p.m. and midnight that there's always so much cake? And you might even begin to predict, well, it's 11:30 on a Friday, and I know for sure that Katy's eating cake right now with like 98% certainty. This is the kind of data that the more we have of it, the more information we can begin to make safer assumptions about when the cake consumption will occur and how often. So that's just one example of sort of how we view the difference between traditional sort of relational data and this like time series data.
Why do we need to use a time series database? That answer can be summarized in 3 main points, which is just scalability, usability, and specialty. Since we're collecting so much data, we need to make sure that we can collect data from a variety of different machines and also host that data and store that data in a distributed system. We need to make sure that our time series database has specific usability features that enable us to query our data more easily, collect it more easily, and analyze it more easily. And it needs to be specialty database for time series data so that it can handle that type of ingest. Make sure that we have the proper replication of our data so that we don't lose any of our data in the event of failures. So let's just go a little bit into more detail about these 3 attributes. But before we do that, I just want to take a step back and talk about how time series is even being used. And the primary use cases are for DevOps and IoT, but also for forecasting. So we talked a little bit about this, but if you are in the financial sector, you're probably going to want to try and create forecasts on your financial data. Also, if you are in meteorology, you want to know like what the weather is going to be like. We talked about that. Maybe if you're looking at seismic activity, you want to be able to predict when you're going to have an earthquake. But there's other types of analytics that you might want to do outside of forecasting. You might want to be able to uncover seasonality in your data to better provide service to all of your clients. You might want to be able to identify certain elements of your data, calculate things like moving averages and aggregate your windows, and calculate means and all sorts of math on your data to gain meaning from it. And one feature of Influx is that a lot of these specialized functions are pre-built that enable you to do both forecasting and analytics. And they're just built-in functions.
Yeah, that's super helpful. I think too, it's important to point out that when we're thinking about IoT, which is the Internet of Things here listed, when you think about any connected device, whether it's a thermostat or maybe something like a Fitbit or a smartwatch or a drone you fly around your house, anything that has a sensor has time series data. Sensor data is naturally time series data. So anytime you're thinking about solar energy, where there are all those sensors involved, that's all time series. And that's an interesting thing to think about because I think it's sort of one of the more, I don't want to say traditional, but it's definitely the easiest example to understand of how time series data works, but it's not the most common that we see at Influx. Our most common use case that we see is what we call DevOps monitoring, which is basically getting insight into your system by gathering metrics. So being able to see how much memory is being used on a given server, how much space is left, all of those things. So those are a little bit of insight into how it's being used. And as we move forward into the three categories that we've been talking about, we'll see that how these three principles apply to all of these very different industries. So I'm going to touch on scalability a little bit first, because if you work in tech, then you've probably heard the question, well, does it scale? And for me, I don't know about you, Anais, but like that question kind of means nothing. It's not quite specific enough because things can scale in different ways. So let's talk about the ways that time series and Influx need to scale.
So you need to be able to scale your data both horizontally and vertically, whether that means vertically, which is having a server that is beefier and putting your data in beefier nodes, or horizontally across different servers. So InfluxDB allows you to scale across both horizontally and vertically and do this with extremely high throughput. And this is in part to the fact that these writes are performed in such a way that they guarantee eventual consistency, which means that if, for example, writes are being made to one server at a different rate than they are at another due to some momentary or temporary problem, that eventually all the servers will catch up with each other and you will have all of your writes being written in the correct way with the correct replication across your entire system.
Yeah, so think about each of these little robots we see here, right? Imagine that each robot is sending back information about its current status. It might tell you whether it's moving. It might tell you what temperature it is. It might tell you its current location or whether it's currently doing the job it was assigned. There are so many things that we can ask for, right? And if each robot is sending back, 10 metrics about its current status, then that throughput grows higher and higher with the number of robots. And that's what we're talking about when we talk about scale. Now, there's sort of an interesting problem, which is that in this case, what we're talking about is that each of these robots would have exactly the same metrics that they're sending back, which obviously isn't always the case.
All right, I was muted. So this slide to me really describes the difference between relational database systems and management systems and time series databases, which is that this is a graph of the various EC2 instances, where the one on the far right is the R4 for Excel, and it is the largest EC2 instance. And with it, if you have a series cardinality of 10,000, meaning that you have 10,000 different unique series, you can ingest over 750 values per second. And you can't do anywhere near this type of ingest rate with relational database systems because of the way that each point is stored in a relational database versus a time series. Time series requires far fewer, like order of magnitude less bytes for each point, and that paired with a lot of really impressive and fancy compression and compaction algorithms enables you to ingest really, really high rates with time series databases.
Yeah, and one also sort of important point for me here is that when we talked before about that eventual consistency model, which you can look up and read, it's like a very interesting like distributed computing problem, but traditional databases, they value durability over everything else. So they want to make sure that a data point is secure before they move on. That's not necessarily the case with time series data because we talk about the value of the data set overall. The reason we can ingest more is one, because of the storage and compression algorithms that Anais was mentioning, but also because if a point is lost, the consequence of that is much lower in a time series database than in a relational database.
Right. To your point, if we're collecting financial data at nanosecond precision and we drop 1 nanosecond worth of data, or we don't have that available to us, that's not going to have a big influence on our predictions. What's more important is
will be the same, right?
Our trend will be the same, and we'll have so many hundreds of thousands or millions of points that we've ingested that we can still create really accurate predictions.
So what happens when the data gets more complex? This is sort of what we were hinting at. So go back to thinking about these robots. Probably in a real world setting where my robots are definitely not taking over the world and are just working very hard in a factory, they probably won't all send back exactly the same kind of data. I might have 2 different types of robot. I have one that tells me its status, and maybe another one that's in charge of repairing the status robots. And so it would send back many of the same metrics about itself, but it might also include metrics about its work, or even a different category of how many robots need repairs. How many have I repaired today? All of that, which is different. And as we collect different types of data, our cardinality increases, which is what Anais was talking about in the previous slide. We increase the number of unique combinations in the database, which automatically means the database has to do more work. And one of the things that time series data and time series databases are really good at is really high numbers of unique combinations. Anais, you might be muted.
Sorry, thank you. Yeah, I was just saying to your point, back to this slide, if even we have a series cardinality of 1 million, so we're gathering 1 million different types of points, we can still ingest incredibly high volumes of data. We can ingest 400,000 points if we're using the largest EC2 instance.
So even as your data gets more complex, your ingest rate remains like the same or very high?
Yeah, it remains really, really high.
Excellent.
Another aspect of time series databases is their usability. And this is most easily described as the fact that, for example, InfluxData has these modular tools. So as part of the platform, there are 4 tools in the stack, and the stack is called the tick stack. And that's because it's a acronym for all of the products, which include Telegraf, which is a collection agent, InfluxDB, which is at the heart of the stack, which is the database, Chronograf, which is the visualization tool, and Kapacitor, which is a real-time streaming data and processing engine. So being able to have these tools be modular allows you to pick and choose what you need for your use case. Telegraf is database agnostic, so if you don't want to use InfluxDB, you can still just use Telegraf. You might not need to do any sort of real-time streaming or data processing or data transformation, so you can elect whether or not you need Kapacitor. And having these elements be modular enables you to use the database and the entire platform more easily.
Yeah, and I think that like part of making something easy to use means that you shouldn't have to spend a lot of time making it work for your use case. And to that end, the tick stack has specialized query languages. When we think about storing data in a traditional database, we think about SQL, right? That's how we interact with our data. In a time series database, we use something very similar. We have a query language called InfluxQL. So maybe you can start to see the similarities. We also have another language called Flux, which is a functional query language, which is not meant to be like SQL. It is meant to be more flexible and easier to window by time. And the idea of having these languages is not, to make another thing for you to learn, because we all know that we have plenty of things to learn for each product. But if you've tried to write queries in a traditional database where you need a very specific time window and you need to operate, say, an average or a moving average on that window, then you know how hard it is. Dealing with dates in traditional programming languages and traditional databases is very painful. So the idea here is that because time is sort of the most important aspect, it should not be hard for you to write queries and interact with data by time.
Yeah, also to your point, Flux was created to just allow you to do even more with your data. It allows you to do things like perform joins and maps. So you can even take this time series data and sort of play with it in a way that feels very relational, which helps you cross the bridge between coming from a relational system into a time series arena. And also, as a part of InfluxQL, there's a lot of built-in functions that are created specifically for time series data. You mentioned some of them, like being able to window your data or create aggregate windows where you perform a mean or a sum across those windows. But there's also built-in forecasting functions and a whole bunch of other specialized functions specifically for time series.
Yeah, and part of making it,
if you don't,
sorry, we're just two on the same page, Anais. We're just two together. But like part of making it usable, right, is that we want to make it available across as many platforms as possible.
And so this includes giving the opportunity for you to use the APIs that are available in all of these languages if you don't want to use InfluxQL or Flux and you want to just use either HTTP endpoint or Go or Python, etc. You can use any one of these languages to query the database and do your time series analysis in the language of your choosing.
Yeah, InfluxData has a full REST API. So basically anywhere you can hit an API endpoint, you can interact with the database. The last category we have is specialty, which we've sort of been hinting at, right? You can't really treat time series data like you treat other types of data. You can't treat it like documents or relational data because the aspect of time is complex. So what kind of goes into thinking about these specialty tools?
So we talked about a lot of the built-in functions that you can use to query your data, but there's other elements of time series databases that are important to consider. When you're ingesting such a high volume of data, you need to be able to do things like rapidly evict data that is no longer valuable to you. So you can set retention policies to either expire old data that you don't care about anymore, or you can use retention policies to downsample that data and only retain lower precision formats or versions of your data, because it's often the case that you don't need to keep your data in nanosecond precision for an extended period of time. That being said, one thing that makes InfluxData unique as compared to other time series databases is that you can store your time series data for an indefinite amount of time if you want to, which can be very important depending what industry you're in, especially if there are special regulations that require you to do so. Additionally, the volume of data is so high that other database systems store the index in memory, but this limits your ingest to your memory size, to your RAM. So instead, Influx has developed what's known as time series indexing, which moves that index from memory to disk so that you're not limited by your RAM, and instead you can store way more points, ingest at a higher volume, and accommodate for really high series cardinality. Is there anything you wanted to add on that?
No, I'm not seeing the correct slide here. There we go. Can you go to the next slide and then we'll see?
For sure.
Okay. Cool. I just was seeing something weird there for a second. I don't know if anybody else was seeing it or if I was just having like a moment. But nonetheless, we talk about time series data in educational ways like this because it is special. It's not like other kinds of data. We've covered a lot of the ways in which it's weird. And the interesting thing is that the tools that we choose to deal with and store and query all of our data really can determine how we spend our time at work, right? The time that we spend learning a new tool, optimizing that tool, getting it to fit our use case, all of that time is part of the decision that we use whether or not to choose a specific tool, right? So one of the things that we want to make sure that we're doing at Influx is making that amount of time to learn it and get started as low as possible. Because time series databases are optimized specifically for time series data, right? They're efficient and performant, and that's what we want you to be too. So if you have time series data, if you have data where time is one of the axes and you know that it's valuable to your data, then what you should be looking for is a time series solution. And that means a specific tool that can solve your problems.
Part of ensuring the developer happiness that you're talking about too is just our time to awesome, and the fact that you can get set up with Influx incredibly quickly. And I wanted to note that if you do decide that you want to play with Influx, there's a sandbox on GitHub that you can just spin up and then immediately start gathering data, system stats from your local machine, and that's probably the fastest way to get up and running. But even if you decide to download it, it is downloaded as a single binary, which makes getting up and running really fast. And then also, You can also use the cloud version, and that likewise takes just a couple minutes.
Yeah, make a username
So
and
now
password,
it's actually,
right?
right, yeah. Yeah, as long as you remember your username and password.
Rude, you know I can't do that.
So about Influx, let's just go into the product a little bit. So the first one I want to talk about is Telegraf. It's also our most popular product. So it is a collection agent for reporting metrics and events, and it's plugin driven. And so it's used to batch metrics from a lot of different sources together. And by batching these metrics together, it reduces the number of atomic write requests, which makes writing more efficient. And you can get data from a lot of different sources with Telegraf. So you can use Telegraf as an input plugin, as an output plugin, as an aggregator, and as a processor. So you can take data from a variety of different sources, ingest sources like just your host system, and you can look at stats like your CPU and I/O and network. You can ingest from common programs like Postgres and Redis, etc. And then also you can ingest from third-party APIs like MailChimp and CloudWatch. And then you can send these plugins, this data, to a variety of different sources with output plugins. And that includes InfluxDB, but also Graphite, OpenTSDB, Datadog, Librato, Kafka, MQTT, Prometheus, and a lot more. There's over 180 plugins, and they have, most of them, I think like 95% of them have been contributed by the community, which to me is a testament of how simple the product is and how easy it is to contribute to. So I also, if you're looking for a project, a contribution project, I recommend looking into Telegraf. And I think that's all I want to say about Telegraf. Is there anything you want to say about Telegraf?
I mean, people love Telegraf, and so do I. And I think it's everything you were saying. It's really simple. And I always say that if like I can set it up in 5 minutes, then anyone can, you know. That Telegraf is just concerned with input and output. It doesn't have to use another InfluxData product. It doesn't need to be a specific kind of data. Like as long as there's a plugin for it, then you can send and receive data. And I think that that's just like a very cool, like very much in the spirit of open source kind of tool. And you should go look at it. And also on the main README in the GitHub for Telegraf, you can use something called the Telegraf Playground, which similar to the sandbox already has everything set up for you in a browser environment, and you can sort of see it at work and play around with it a little bit.
Oops. So next we have InfluxDB, kind of the heart and soul of the entire platform. And so we've been over a lot of these details, but it's purpose-built to handle time series data. One example of that is the time series indexing that we talked about. It offers that SQL-like query language called InfluxQL. It offers Flux, which allows you to do any sort of scripting that you want to do with it. And I feel like we've talked ad nauseum about
well,
the database
because
already.
Yeah, well, the database is very much like it was the original product, right? Like before there was Telegraf or Kapacitor or Chronograf, there was InfluxDB. That was sort of the very first open source project for the company. And one thing that I sort of like to talk about is this. We haven't used the term purpose built yet, but everything we've been talking about as far as like specialty is what we mean. This is a purpose-built time series database because initially our CTO built this database in response to like a specific problem he was having. And I think it's important to note that the database is written in Go, and there's no underlying database. So sometimes you'll see databases which are maybe forked from Postgres or something like that, or MySQL, and then they have a layer added to them. InfluxDB is just go all the way down. There's no underlying database. All of the work that it does is by our like amazing engineering team. And that's why we're so confident in how it performs, is because we have full control of every part of the database's performance.
And then another element of the tech stack is Chronograf. And Chronograf is the visualization layer for the platform. And it handles an integrated user experience across the tech stack and allows you to do data exploration, create alerts, including threshold alerts and dead man alerts. You can create dashboards. You can also bring in predefined dashboards or export dashboards that you've created. It also supports multi-tenancy, and so you can support multi-tenancy capability and also support multiple organizations. So that enables you to implement role-based action control, access control. And it also has a great interface for building queries, which is just clicking through. So even if you are unfamiliar with SQL, you're unfamiliar with InfluxQL or Flux, and you don't know how to use it, you can just use the GUI to generate all of your queries in a really natural manner. And then also, it's the same with creating any sort of alerts. You can just click through options to create alerts. It'll generate a script for you, and that's a great learning tool for learning all of these languages.
Yeah, I like to think of Chronograf as basically like the interface for the rest of the platform. You can do pretty spectacular data visualization from there. But if you're already using something for visualization, then you can still use Chronograf. You can use it to manage your organizations, to sort of like manage all the multi-tenancy Anais was mentioning, and set up your alerts, manage your retention policies, all of those things. And especially if you need to be building dashboards and sharing them, that import and export is very cool.
And then finally, we have Kapacitor, and that's our real-time streaming data processing engine. So you can take data from Telegraf, do some sort of data transformation that you want with it, and then send it to InfluxDB. Or you can take the data that's already in Influx, pull it out, do another data transformation to it, send it back to InfluxDB. And then you can also process alerts and send those alerts pretty much anywhere. So it integrates with Opsgenie, Sensu, PagerDuty, Slack, text, etc.
Yeah, I think it's interesting. A lot of times when people talk to me about using Kapacitor, they often talk about data roll-ups. So being able to collect high precision data and then roll it up into either an average or some kind of aggregate that works better for them. Because although InfluxDB can store indefinitely, that doesn't always mean you have indefinite hardware, right? So being able to wrap up some of that high precision data into kind of a snapshot is something that you can use Kapacitor for. And you can also sort of like offload work from the database over to Kapacitor. So the database has something called a continuous query, which is basically where you want to keep calculating something as in real time as you continue to collect data, which is very useful. But the more continuous queries you have, the busier your database is. So you can offload those continuous queries to Kapacitor to free up your database to do all of the writing and reading and storing that it needs to spend its energy on, and create Kapacitor tasks to instead do the continuous queries for you.
So this is just a list of all the places, all the alert handlers that you can send your alerts to. And then you can also use Chronograf and execute a shell script, for example, too, based on an alert, which is also a really cool feature.
Yeah, I mean, basically, when it comes to Kapacitor, you can write some very customized code. You can add in a lot of scripts to do whatever it is you need to do to your data, right?
So now let's go into talking about how you write data. So InfluxDB has its own special ingest format, and that's called line protocol. And it looks like this, where you have a measurement separated with a comma that then indicates your tag keys and your tag values. And then you have a space, and you include your field keys and your field values. And then finally, following that is your timestamp. So if I was looking at stock price, for example, my measurement might be stock price. I would include my tickers for my tag sets, and then I would include the actual values of the price and the currency type in my field set, and then I would have my nanosecond precision. But it's worth noting that if you're using Telegraf, then you don't need to handle this sort of input yourself, because Telegraf will convert the data into line protocol for you.
So here's sort of, oh, sorry, the most basic InfluxQL query, which is our SQL-like language. So you can see this is a basic select statement, which if you know SQL, you will already be familiar with. This is select the measurement, which we saw in the previous thing, usage system, from the database Telegraf. .autogen is the retention policy that on that database, where our condition is where we want the time to be greater than the dashboard time. And in this case, dashboard time is a variable. It usually means within the past 5 or 15 minutes or so. And the CPU equals the CPU total. So basically, this is just getting us a selection of fields for CPU usage that belong in the database Telegraf under the retention policy called autogen in the measurement usage system.
And then here's a Flux query example. It's really similar. It's just kind of a translation of the InfluxQL query that we saw. We select the bucket from which we are taking our data from, and we specify a range with the start time. So we want to take the data from the last hour, and then we filter based on the measurement field and CPU, and then finally we can yield this result. So let's go over a quick demo. Bear with me for a second while I figure out my sharing preferences.
Yeah, we just want to see just a brief version. So now we're looking at Chronograf, this is sort of its homepage. We're seeing,
so
go ahead, Anais.
Oh, no, no worries. Oops. So I can just go in here, and I've ingested some weird stuff into my Telegraf, but you can just ignore that. But I can just go through and click what I want to look at, and all of a sudden a Flux script has been created for me, and I can click Run Script, and then we can see our data in a table format, or I can go to the Visualization tab and select a line visualization, and now I can see all my different data visualized as a line. We have other options.
Way cooler as a line.
Yeah, exactly. We have other options like single stat, gauge, table. You can customize the look of it as well. And then I just wanted to show an example of sort of some custom functions. So here is an example of forecasting functions that are built in. I used InfluxQL's Holt-Winter built-in function to generate a prediction on the water levels for this stream. And so this magenta line here is actually the forecast that was created. So that's pretty cool. And then the last kind of element here is creating anomalies with the alert builder, where you just name your anomaly. You select whether you want it to be a threshold, relative, or deadman Dead man is when you're not receiving any data. You select the retention policy and the tag and the field that you want to alert on. And I said, you know, when this alert is greater than 8.8, send me an alert. And then you specify where you want to send the alert to. You save the rule, and that's all you have to do to set up those type of alerts.
Hey, Anais, would you mind going back to that alert page for a second?
For sure.
Just something I like to sort of highlight is that when you're starting to build the alert, go ahead and select one of your rules. When you're building them in the conditions section, as you're building it, you can see in that green area, it's already showing you like when you would get this alert. So it's showing you like right now, this is when the conditions for this rule or this alert are already met. And sometimes that means that this is a good time to adjust, because if you get alerts constantly, then you get alert fatigue, you don't pay attention to them, right? Or maybe it means you need to make a change in your system. But I think this is like a cool thing to pay attention to as you're building the rule, just so that you know like how often you might get this alert, because getting them too often is sometimes just as bad as not getting them.
Yeah, I completely agree. This was just kind of, I don't even know if this alert works anymore. I probably should have picked a better one.
No, I think that it's a great example because of that. Like all of mine are like that.
And then I just wanted to show the same thing. So you can use InfluxQL here as well, and select through the same options in a very similar way and create your InfluxQL queries. So
yeah, I think that's like a great quick demo to run through. Like that you can do all of that in the sandbox Anais mentioned. You just need Docker, and then you can sort of just spin up the entire stack. And I think it's important that like we're interfacing with the entire platform through Chronograf right now. So, you know, we're querying the database, we're using Kapacitor to set up the alerts, and most of the data that Anais is looking here has come in via Telegraf. So it's a nice way to sort of realize that this is an interface for the whole platform.
Yeah, so the reason why my visualization worked very well is because I haven't been using Docker in a while. So
yeah, that happens.
But yeah. Oh no.
That's okay. We're gonna very quickly. we got so excited about these things that we went a little longer than usual, but that's okay, because I think it's important that we go over a couple use cases so that you know, like in the real world, practically like who's using this. So one of my favorites is Bbox. They're a company that makes basically batteries to help support rural areas, so that people can keep their lights on when they don't have access to a power grid. And they use Influx to monitor how much battery life is left, so that people can replace their batteries before they run out of power. And they also use it to monitor just like the overall health of the battery, right? And so the quote here says, "We analyze over 70,000 hours of data every night, 500 million data points to produce alerts for our technicians. Having this real-time data in the cloud makes it possible to identify trends, usage patterns, and even detect problems before they exist." And that's really like the whole point to this platform. Tesla is also an interesting use case because, like I mentioned, all sensor data is IoT data. So this is a really natural fit, right? Making sure that sensors are sending back precise information, getting visibility into their performance, making sure you know when to clean them or replace them. That's all super important. And Comcast is also very cool. It's a DevOps monitoring use case. But let's go to the next slide so we can see some others.
So Influx and Hulu worked together to create a really robust pipeline where they were able to scale their ingest to over 1 million metrics a second using InfluxDB and Kafka. And so they were able to navigate away from their traditional publish and subscribe system to using Kafka, and it's just kind of a seamless fit. So a lot of people now are starting to use Influx and Kafka together to handle ingest loads that kind of have never been handled before. And then CERN is probably my favorite use case because it's open source. CERN was trying to find the God particle, right? Which is, I think, the formation of a quark. And they do this by colliding a bunch of subatomic particles together in a large hadron collider. And they have to monitor all of their equipment, all of their computers, and then also, track all of the particles that come out of the collision, which is like millions of particles and stuff. So they were using Influx to monitor a bunch of different machinery, and they were able to find or understand the formation of quarks all using the open source. And then finally, Houghton Mifflin Harcourt is a publishing company that used Influx to gain visibility into their AWS account. So they were able to get all the sort of CloudFormation stats from using Influx instead, and able to narrow in on their costs and save a lot of money. And they also provide a learning tool for students, and they were able to do application monitoring as well. So they use Influx for multiple uses, and kind of were able to store all their different data sets in the same platform, which is nice when you get to kill two stones with one bird. I think.
Yeah, so now
we kind of went over this.
Yeah, but that's okay. We still like to tell people, now is the time for you to try it out. And right now that means that you can go download it. You can go to our downloads page. You can go to the GitHub. We also have a pretty cool community. We have a community site, and we also have a community Slack where we are often there answering questions and helping people set up their stack. And there's the sandbox available if you don't want to like install anything. And right now, you can try out the sort of, sorry, my brain melted a little bit. That happens sometimes when you get to these. But yeah, you can go to the downloads page and you'll see all the information about like how to access these in all their various forms.
Any questions?
Great. Thank you all so much. We do have a few questions that have come in. The first question that we have is, which programming languages have been used in the platform's development?
Yeah, so it's a great question. So almost everything we've talked about today is written in Go. The database is fully written in Go. Telegraf is fully written in Go. Chronograf is JavaScript because when you got to visualize, that means it's time for JavaScript. And we also have a cloud offering that uses some Elixir, but the products themselves are written in Go, and then we use JavaScript and or Elixir to sort of make them viable for the browser.
Great. The next question that we have is, can you talk a bit about what options there are for acting on metrics?
Anais?
Sure. I'm not entirely sure what you mean by acting, but I think to me, I interpret that as just being able to create alerts and then make some sort of changes and act upon the data once you've created an alert and your data is exhibiting certain behavior. And like I said, you can either send an alert to yourself and then go investigate what's causing that alert and then make some changes manually, or you can use Kapacitor to execute a shell script based on the alert that you have received.
Yeah, I think that's fair. It's a little bit about what taking action means to you, and there are definitely use cases where we see people like fully managing their containers with Kubernetes through Kapacitor, right? And saying like, hey, when this container goes down, like I want you to send me this alert, and I want you to restart the service, and maybe even set up 3 more containers, like that sort of thing. So it kind of depends on what taking action means in your system, but Anais is totally right. There's a lot of ways to do it.
Great. We do have one more question. So audience, if you do have any more questions, please ask them into the questions panel. The last question that we currently have is, what does the stack do to enable automated alerting and actioning on metrics coming in? And how do you perform downsampling?
So the automation all happens through Kapacitor. That alerting all happens through Kapacitor. For downsampling, you have 2 choices. You can either create individual continuous queries to create those downsamples, or you can handle a bunch load of continuous queries through Kapacitor. And then that way you can automate all of your downsampling.
Great. Is there anything else you guys would like to add, since that was our last question?
No, I don't think I have anything else, except that we'd love to see you become part of the community. I've listed my email, and Anais is here, so you can reach out if you have questions. Reach out on Twitter. We're always happy to help. We want you to have a good time using the tools, and to let us know if you need help.
Well, awesome. So with that, I'd like to thank you, Anais and Katy, for a great presentation today. I'd also like to thank today's sponsor, InfluxData, for providing the audience with a great webinar presentation. And lastly, thank you to everyone who attended today. We hope you learned something new that will help you in your developer career. Have a great day, and we'll see you next time.